All right, moving on to page 60, our final video of length of daylight. We are now crossing the equator. We're going to investigate Houston, compare it to a new city, Porto Alegre, Brazil. So Porto Alegre is in the southern hemisphere at 30 degrees south. Houston's in the northern hemisphere at 30 degrees north. So here is our data for Porto Alegre. I typed it into both Desmos and my calculator, just looking at just Porto Alegre on my calculator. There it is. You can kind of see it's different from what we've seen before. Here is Houston as well. So Houston is now being drawn. And we can kind of see that because they're both 30 degrees away from the equator, their length of daylight mirrors each other. Where Houston has its longest day in the summer. Now in the southern hemisphere, Porto Alegre, Brazil has its shortest day in the summer, where Houston had its shortest day in the winter. Now Porto Alegre, Brazil in the southern hemisphere has its longest day in the winter. These are the equations that I got from the calculator. The difference between the calculator equations is that this was plus a negative, and for the northern hemisphere, and now it's just plus. And I think the better difference is from Desmos. We now have a negative here in front of the 116, front of the whole equation. That flips our graph over. So now it looks like this. It looks like starts at long day, goes to short day in the middle of the year, and then back to long day versus northern hemisphere look like that. So how they compare? Same length of daylight in different parts of the year. They're mirror images. They're reflections of each other. We went and found the summer solstice. Its maximum is actually in the northern hemisphere's winter, but that's their summer. Still around the same December, Christmas time, end of the year. Still around 14 hours, 8 minutes. And then our minimum winter solstice, again, happens in our summer, their winter, around the 21st of June for about 10 hours and 15 minutes. So how's the maximums compare? It's the same amount of daylight, but they're in the opposite parts of the year. Did want to show you that you should be recording all of this on this page here. This is page 59. This is my summary table. I'm just going to walk you through it here. The first row, I have the equations from the calculator and from Desmos of Houston. The ordered pair, sorry about that little mishap there, about June 21st for the maximum, that much daylight, and the minimum in December with that amount of daylight as well. Don't have any intersections here because we're only looking at one graph so far. The maximum is the summer solstice. It's the longest day of the year. The minimum is the winter solstice, the shortest day of the year. We added Philadelphia to that. I have the equations from the calculator and from Desmos. The longest day of the year, notice it's still approximately the same day, June 21st. Still approximately the same shortest day of the year in late December. And we can see how the Philadelphia's longest day of the year is longer and its shortest day of the year is shorter. And then we're also able to add the equinoxes here. So the spring, these intersections are equal times of day and night. That's kind of what the word equinox means in Latin. The first intersection is going to be the spring equinox. The second intersection is the fall equinox. They should happen in the middle to late March, middle to late September, and they should both about have 12 hours of daylight and night. When we go to Porto Alegre, we have the calculator equation and the Desmos equation as well. Notice our longest day of the year now happens in December, so it kind of flipped from our previous. The shortest day of the year happens around the same time, June 21st, even got the same 172. And we have the length of daylight for those days kind of match what we had for Houston as well, approximately. Just a model, it's not perfect. And then our equinoxes happen about March and September, and then they should both have length of daylight of approximately 12 hours as well. Your goal is to choose 3 cities one northern hemisphere, one southern hemisphere, and one closer to the equator that is not Quito. And you're kind of going to do this whole thing for your new cities as well. So first step is to select your cities and have them checked by your teacher. And then you're going to go find your data. And then you're going to use either Desmos or your calculator and find the equation, the max min. And then once you have your second city, you find the equation, the max min, and the intersections between that second city and your first. And then with your third city, you're going to find the equation, max min, and the intersections between your third city and your first city. Let us know if you have any questions. I did want to show you on Desmos as well. So I have all three sets of data. So here's Houston, Philly, and Porto Alegre typed in. I just scrolled one over to the right and was able to type in just Y2 and start typing in there. I had Y1 is approximately that equation, and it gave me A, B, C, and D down here. Did the same thing for Y2, Y3 as well. It gave me this beautiful graph, which we expect to see from your cities as well.